Now, let's try this one. This time we're doing cubic function, and we've got them set up in a very, very similar form to the turning point form of a quadratic. This one is a outside of x minus h cubed instead of squared, plus k. Now, we use it in the same sort of way. A lot of it's similar, there's a little bit of difference as well. First of all, your cubic shape is generally going to be like this, where that's a stationary point there, it's got a horizontal gradient. Because it's horizontal like that, we could actually call it a point of horizontal inflection. So it's a type of stationary point. It's not a turning point because it doesn't turn around, but the gradient is still zero. Now the way A, H and K affect this, H and K are calculated exactly the same way as they were for the quadratic, and they give you the coordinates of this stationary point here. So it has a stationary point at HK. So, and then we'll work it out on this one in just a moment. The A value, once again, is a dilation factor, just like with quadratics. Numbers bigger than 1 would bring the graph closer to the y-axis, make it skinnier. Numbers less than 1 would make it fatter, away from the y-axis. Negative numbers will make it go the opposite direction. And that's all you need to know. Now we can go and graph this one. So let's just have a quick look at this. Now, it doesn't look 100% like this because this has got 2 lots of x, whereas this generalized formula has 1 lot of x. It isn't going to make a huge degree of difference. If you have a look at how the book does it, it actually tries and factorize this 2 out so it makes it look like that. But in the end, it's not necessary, because to find the x-coordinate of this horizontal point, all we need to do is just make the contents of the bracket equal to 0, and whatever the x-coordinate is what we require. I now have the x-coordinate of this horizontal one. So the y-coordinate of it is, that's going to be my h value will be -2, my k value is going to be -3. So I know that this graph is going to have a horizontal point at -2, -3. Then all we need to do is find out where it cuts the x-axis and where it cuts the y-axis. Once again, make x equal to 0 to find y equals 0 to find x. Pause the video, you have a go at that, see if you can find where it cuts the x and y axes, and then see if you and I get to the same answer. Now, here's my working. Making y equal to 0, I reckon the x-intercept is around about -1.1. Making x equal to 0, the y-intercept is at 29. Positive A value, so it's going to be the normal shape. Horizontal inflection we've worked out is going to be at -2, -3. So -2, -3, is around about there. So the graph comes up, flattens out, and then it keeps going up, something like that. And that's roughly what it looks like. So there's one of the questions where you're given the function and asked to draw the graph. I'm now going to rub this out and give you one where I draw you the graph and you've got to work backwards to the function. Very good. All we need to do now is find the A value. We are given an extra point, the point 0.5. If we substitute that in, we'll work out A. You might want to pause the video, have a go yourself, and see if we get to the same value. So I think the A value should be -2, which agrees with the fact that it's now pointing in the negative direction. So the final function is -2 outside of x minus 1 all cubed plus 3. And they're the 2 types of cubic problems you're going to come across. So have some practice with them, and I'll see you in class and we'll work on them a little bit more.